Thank you very much, Jeff, and thank you for inviting me to this very important workshop. My presentation will be on tackling the e-waste challenge, because as you say, it's definitely a challenge and it's an issue of growing concern, worldwide issue. And I will zoom in on 4 topics today, which is the ICT, internet waste, let's say, then critical raw materials, the all actors principle, and I will say a few words about digital thread. But before I do so, let me just say what our why is. So what is the why of the WEEE Forum? The WEEE Forum is a club of producer responsibility organizations. And our why is to tackle the worldwide societal challenge of e-waste, because we know from the United Nations research that e-waste worldwide is growing by 1.8 million tons of waste every single year, and there is no tipping point in sight. So we see this as a starting point of interest in this topic. We want to research this. We want to find solutions to mitigate this topic. And you also mentioned awareness, Jeff, in your introduction, and it all starts with awareness. If people are not aware of that there is an issue, we will not make much progress. So you will remember this Mount Recycle More that was launched last week at the G7 summit. And it's a part of an awareness campaign, let's say a worldwide awareness campaign of the growing issue of e-waste. So before I introduce my 4 topics, let me briefly tell you who we are. Who is the WEEE Forum? What's the WEEE Forum at a glance? We are a worldwide organization of 43 producer responsibility organizations on 5 continents. In the UK, we often talk about producer compliance schemes, and REPIC is our British member. And so we are represented, let's say, we have chapters or we have members in all 5 continents. Secondly, we are representative of the entire sector of electrical and electronic equipment. All the PROs in the WEEE Forum are mandated or controlled by producers of electrical and electronic equipment. Last year, the PROs collected 2.7 million tons of e-waste, which is the equivalent of 270 Eiffel Towers. And since the early 2000s, that's approximately 22 million tons of e-waste collected. And our mission, let's say, is to become the world's foremost e-waste competence center, excelling in the implementation of the circularity principle, meaning that you look at the value chain and you look at the different sections of the value chain and you try to make sure that the whole system works better and that products remain in the system for as long as possible, that you repair products, we reuse them, we prepare them for use, and we recycle them. So very briefly also, the scale and the nature of the problem. So just in 3 charts, as I said, the e-waste is one of the fastest growing waste streams in the world. The United Nations has estimated that by the year 2030, there will be 75 million tons of e-waste. So as I said, every year it's 1.8 million tons larger, and there is no tipping point in sight. Secondly, every household in Europe contains on average 72 devices. We don't realize, but it's much, much more than you would expect. And all these devices have components and critical raw materials, the supply of which is limited. And then, as I said, electronic equipment contains 30 of the critical raw materials that have been defined by the European Union as being critical. So of all the issues around WEEE, I will zoom in on 4 issues: the internet waste, digital thread, EPR and all actors, and recovery of critical raw materials. Let's start with the recovery of critical raw materials. This is not a loose term. The European Union has defined it as being those critical raw materials are those raw materials which are economically and strategically important for the European economy, but have a high risk associated with their supply. So for the renewables industry, for example, wind farms, and of course also e-vehicles, e-mobility, defense and space also, totally rely on critical raw materials and rare earth elements, which other countries are sitting on. So the supply of which is actually very important, but there is a high risk associated with it. So just to give you an idea, DRC, the Democratic Republic of Congo, is sitting on 68% of the cobalt. China is sitting on more than 95% of most rare earth elements. So, and especially Europe, European Union is highly dependent on the supply of these critical raw materials. And so it's very important to secure this supply, and in order to make also the economy more resilient. And so how can we mitigate the supply risks? And the European Union has studied this for many years, and they have said, for example, we should foster substitution of the current critical raw materials and products. We have to make sure that import is more reliable. So instead of importing from politically risky countries, such as Congo, let's try to import from other countries. Let's make the value chains more resilient also. Do we really have to import every single screw from Asia? Diversified supply, that's another element, and domestic production, meaning mining in Europe, which is a very sensitive topic, of course, extraction, and because there's very little going on at this minute in terms of mining. And the last means, let's say, to mitigate supply risks is by recycling the critical raw materials that are currently sitting in the e-waste. And as you can see in the next on this chart, many critical raw materials are not recycled. So, or if there is a recycling going on, it's very, very low. So for fluorspar, for example, it's just 1%. For germanium, it's only 2%. Actually, this 2% means the extent to which recycling contributes to meet EU demand of CRMs. So germanium, to take this example, is contributing 2% to the demand of CRMs. That's very little, and we should stimulate the recycling of critical raw materials. So the WEEE Forum has been involved in this project, Sea Waste, which came to an end just a few weeks ago. And it sought to, we created a set of normative requirements that seek to improve the CRM recycling from WEEE and waste batteries. And also we created a voluntary certification scheme. So just to visualize what we're talking about, there are many technologies currently available that do recover critical raw materials. And some of these technologies are business practice. However, they are not sufficiently scaled, or they are not removed from WEEE in sufficient quantities. They are not traced, and so on. So everyone knows that palladium, for example, gold and silver is being recovered from PCBs, printed circuit boards. So it's a current business practice, but we could be more ambitious in this field. But the point now is that there are technologies available to also recover the materials in fluorescent powder in fluorescent lamps, for example, and the CRT TVs and monitors. But they are not current business practice for the very simple reason that the price is not good enough. And we have researched in this Sea Waste project that only an extra contribution of 1.10 euro per 1,000 lamps is sufficient to make the recovery of fluorescent powder from lamps a viable business proposition. So very often all it needs is a little nudge, let's say, to start recycling these important critical raw materials, such as europium in the case of lamps, yttrium, cerium, and so on. And so the roadmap of the Sea Waste project is to say, let's make sure that the standard that we have developed, the normative requirements, how to handle these WEEE items, how to treat them, how to recycle them, to make them mandatory, because now standards are voluntary, they are not mandatory. And also we should integrate the standard into the Senelec standard into the existing standard. We might consider also clustering products in such a way that it is much easier to have access to the critical raw materials. That's another thing that we could consider. And so there are a number of suggestions that we are making here in the roadmap. If you are looking for more information, go to our website or type sea waste and you will find the final report. That was the first issue, critical raw materials. Another issue I would like to present to you is the all actors approach and the principle of extended producer responsibility. Our industry is regulated by the extended producer responsibility, meaning that producers are also responsible for the collection and the management of e-waste arising from the products they put on the market. So, and the thing now is that despite irrefutable progress, so we see that the collection of e-waste has gone up considerably in the past 10, 20 years. Despite that progress, we see that member states do not reach the regulated collection targets of 65% of what was placed on the market in the past. And so that's an issue of concern. As you can see, only Switzerland, actually the statistics of Croatia and Bulgaria are probably shaky. So it's only Switzerland that really goes beyond the target, but Switzerland is not a member state of the European Union. And but as you can see, it's a challenging proposition for almost all the member states. And the peculiarity of our sector is that that a lot is going on outside the formal system, meaning the system that properly reports, properly collects, and treats the e-waste. So only 55% of WEEE is reported as officially collected, and then we have no idea to what happens to 20% of it. So that it disappears in other streams like illegal exports to Africa. It disappears in metal scrap flow. Many consumers throw away their hairdryer in the waste bin, and so on. So that's a peculiarity of our sector. And so we believe that in the WEEE Forum, and many of our friends, let's say believe that the time is ripe for an update of the WEEE policy approach based on the enhanced extended producer responsibility principle. And the first element is that we believe that all actors should come together and should be assigned clear responsibilities and clear roles in solving the e-waste challenge. So it's not only a responsibility for producers, because at the end of the day, EPR doesn't stand for stands for extended producer responsibility, not exclusive producer responsibility. Other actors in the market that have access to WEEE should also bear responsibility. So basically, we are saying that legislation should say that if you have access to WEEE, you should have distinct responsibilities. So, and that's the second principle, the WEEE available for collection. So the principle that PROs are only legally accountable for the WEEE to which they have access should be enshrined in WEEE legislation. And we should bring all these actors around the table in what we call a coordination body. There are examples in other countries, such as Italy and France, where this works quite well. And basically, what happens in a coordination body is that the clear assignments are attributed to the different partners in the network, the different actors in the market, and specific roles. And the third element I wanted to draw attention to is the importance of monitoring the flows. And I know that our British member, REPIC, is very involved in research on this matter. So it's very important to understand what's going on in the market so that you can tailor-make your policies to address these issues. So monitoring the flows is exactly what I presented earlier. It's knowing how much is actually collected formally, it's reported as collected, how much is disappearing in the waste bin, how much is illegally exported. This is critically important to have sound policies. The third issue I wanted to share with you briefly is to what extent are they enablers? Is the Internet of Things and ICT in general, are they enablers of a digital circular economy? Because that's, of course, a key question. So we know that we assume that ICT can be an enabler, but on the other hand, they also give rise to waste, to e-waste, electronic waste. And so we looked into this, we researched this as WEEE Forum in collaboration with ITU, the International Telecommunication Union, which is a United Nations body. And we identified what are the demand drivers, what are the political drivers, economic drivers, technological drivers that actually make sure that we have more and more internet applications, and what it means for future e-waste arising. So you can also download this report from the internet. And because one of the conclusions or one of the findings is that it's like an iceberg where most of the iceberg is underwater. You don't see it, so it's not visible. We talk about the cloud, but the cloud depends on a cloud data center to operate properly. And a data center is composed of materials and components and so on. So it's very important that we draw attention to this problem, because also they consume a considerable amount of energy. And when we talk about e-waste, everyone thinks about their phone, the smartphone, and or the washing machine. But there are so many components and interconnected applications that also contain the critical raw materials and that contain the elements that we need to recover. So that was let's say an element or research to highlight the importance of looking or keeping an eye on these elements. And so the global waste footprint is greater than we see. So there's a big chunk that we don't see because it's hidden in, let's say, the cloud and the data centers. And but the jury is still out in terms of what is the net effect on the economy. On the one hand, ICT can play a role to make it more circular and sustainable, but on the other hand, it also means that you require more materials to make your products. And the fourth element, and I see I am still in time, is I wanted to say a few words about a digital thread. And we just started a new project with many other associates, organizations. It's called Circ Thread. And the opportunity that you're looking at now, and it's really very topical in Brussels and among EU organizations, is to say that the circular economy provides a growth model based on product reuse and material recycling routes to ensure far more materials contained in products stay in the economic loop, benefiting the sustainability of the economy and the environment. So that's the opportunity. But the challenge is that the opportunities are not yet fully exploitable because there is no or insufficient digital infrastructure with associated decision-making support across a product's life cycle among all stakeholders. So practically speaking, we should design and develop a system, what they call this a digital thread, that allows the reuse outfit to understand what is actually broken and what has to be repaired. Also understanding from the consumer why or which machine do you have and what needs to be done to fix it. There's also a link between design and manufacturing. Also what happens at the shop and so on. So we need to build this digital thread to allow much more traceability and transparency of the value chain. So we started this project just a few weeks ago. And it's also part, you can also see it as part of the digital product passport discussions. I don't know to what extent this is also being discussed in the United Kingdom, but in the European Union, there's a huge debate going on at the minute as to how to design a digital product passport. What does it mean? What technologies? How would it work? How do you regulate digital product passports? So with this, and of course, all this fits into the European Green Deal that mentions the electronic product passports, and also refers to the need to provide information on the product's origin, composition, repair, dismantling of possibilities, and so on. So the challenge now is to really tap into these possibilities. And thank you very much for your attention. And I hand over to Jeff.